Sound waves. A speaker is shown in the figure which is producing sound, and molecules of the air are closer, then far away, then closer, then far away, then closer, then far away. In this way, energy is transmitted by the molecules in air. The molecules are closer, then this is known as compression. Molecules are far away from each other. It is known as rarefaction, and in this way energy is transmitted from molecules of air from one place to another place in air. This figure shows a tuning fork. A tuning fork is a device that produces sound of desired frequency. The frequency is printed on the tuning fork. In the box there are various tuning forks having their frequency printed on them. That is, this instrument is producing a particular frequency only. Therefore, it is used in laboratory. In the figure 1, it is a U-shaped bar which is joined with a handle, and handle is used for holding the tuning fork. When the end, that is prong or arms of tuning fork, are stuck on a rubber pad, they start vibrating, and these vibrations are transferred to the handle also. The handle also vibrates in up and down direction, whereas the arms or prongs of tuning fork vibrate in horizontal direction. That is, angle between the vibrations of U-shape and handle is 90 degrees. Here, a pendulum is hanging in a mean position and a vibrating tuning fork touch it. The arms or the prongs of tuning fork touch it, then it goes to one direction, showing that there is vibration in the tuning fork. Second diagram, tuning fork is placed in a glass which is filled up with water. Then the surface of water starts vibrating, and ripples, that is up and down, on the surface are produced. In the last figure, another mode of putting tuning fork inside the glass, then vibrations again start due to vibration of tuning fork in water. Here is the example showing the vibrations. A food can is closed with a stretched balloon one side, and a mirror piece is placed on it. In the figure, source of light is giving a ray of light on the mirror, and a person is speaking in front of the food can so that air inside the food can vibrate the stretched balloon, as a result of which there are vibrations on the mirror, and the reflected light on the wall is also vibrating. This shows the vibrations are on the wall experimentally. Sound cannot travel through vacuum. Vacuum means air is not present there. The astronauts who land on moon or walk in space talk to one another through radio waves, electromagnetic waves, because sound waves are the mechanical waves. They cannot travel in vacuum. Sound waves require material medium for their propagation. This is another activity here. It proves that sound cannot travel in vacuum. There is a transparent glass bell jar in which vacuum pump is connected and electric bell is kept inside it. When the air is present inside the bell jar and electric bell is switched on, then sound is audible outside. If vacuum pump is used to suck out the air, that is, vacuum is created inside the glass jar and again the electric bell is switched on, then sound is not audible outside. This proves that sound waves cannot travel in vacuum. Sound requires material medium, that is air, for its propagation or traveling. This is experimental proof that material is required for propagation of mechanical waves. That is, waves are of two types, mechanical waves and electromagnetic waves. Electromagnetic waves do not require any material medium. Light is the example of it. Light travels from sun to earth and vacuum is in between. Therefore, due to the property of electromagnetic wave, they can travel in vacuum. We are able to receive light from sun to earth and sound cannot be observed as shown in the activity just we have discussed. Definition of sound: the form of energy that makes sensation in our ear is known as sound. Another definition of frequency here: the number of vibrations in 1 second. Vibrations we have seen in tuning fork previously. I am repeating, the number of vibrations in 1 second is called frequency. Its unit is hertz. Hertz is the name of scientist. To give the honor of to the scientist, unit is hertz, just like Newton, Joule and other units. The reciprocal of time period is also frequency. That is, 1 upon time period is equal to frequency. Time period: the time taken by the wave to complete one oscillation is called time period. Its unit is second. Amplitude: the maximum displacement when the sound wave or any wave travel in a medium, then particles have different displacement. We have to select only the maximum. The word maximum is here for amplitude. I am repeating again, the maximum displacement from the average or mean position of vibrating particle is known as displacement. Next definition: wavelength: the distance traveled by the wave during one complete cycle, that is one vibration, is known as wavelength. Wavelength is given by the symbol lambda and it is measured in meter because it is a distance. The wavelength of transverse wave is the distance between two peaks or distance between two successive or consecutive crust or troughs. In a transverse wave, example, just we are throwing a stone in a water pond, then water starts moving up and down and transmit energy from the place of the stone to the bank of the pond. Therefore, the mean position as shown in the figure is shown here and the particles vibrate just like up and down. Up portion, that is known as crust, and the downward portion is known as trough. These crust and trough are produced on the surface of water as shown in figure, and one complete cycle is also shown, that is one crust and one trough makes a one complete cycle, that is one wave. Wavelength is distance between the two consecutive crusts as shown in figure, or it is distance between two consecutive troughs, or it is the distance traveled by the wave in complete cycle. Wave is a vibratory disturbance which carries energy from one point to another point. Now the velocity of wave, the distance traveled by the wave in 1 second, is called velocity. That is just like simple the definition of velocity. Velocity is equal to displacement upon time. Therefore, here is the similar definition for sound traveling in a direction. Types of mechanical waves. Number 1, transverse wave. Example, light waves. Number 2, longitudinal wave, sound waves. In the light waves, electric and magnetic vectors vibrate in perpendicular direction to each other. Therefore, light waves are also transverse in nature. Requisites of medium for sound propagation. Propagation means traveling and requisite means requirement of medium. Number 1, medium must be elastic. Elastic, we are having different type of material like rubber. If we are stretching a rubber band and leave it, then it returns back to original position. That is, elasticity is the property which brings the rubber band in the original position. Medium must have inertia, that is, mass or particles must be inside it. Then the velocity of wave, that is longitudinal wave, is given by V is equal to under root E. E means elasticity divided by density of material, small d. Mechanical wave speed is shown in various figures. In vacuum, no motion. Mechanical waves cannot travel in vacuum. No particles are there. In gas, particles are far away. Velocity is least. In liquid, particles are closer and velocity is more. There is more elasticity. In solid, there is highest elasticity, and due to highest elasticity, sound wave travel fastest in the solid. In the table 1, velocity of sound in various medium is given. It is given at room temperature. In air, velocity of sound is 331 meter per second. On increasing temperature, velocity increases. Therefore, at room temperature, it is 343 shown in the figure. In iron, it is 5130 meter per second, and in lead, that is more, 1150 meter per second. That is, in comparison to air, speed of sound is more in iron. Transverse wave, a wave in which the particles of medium vibrate in the perpendicular direction of the propagation. Propagation means traveling of wave is called a transverse wave. The elevation or hum, that is up and down, elevation or hum in a transverse wave is called crust. Crust is the upward portion above mean position, and depression means below the mean position. In a transverse wave is called trough, as shown in the figure. Mean position is shown by x-axis straight line, and then vibrations in upward direction. Peaks are shown here, that is crust, and trough at the bottom means below the mean, it is trough, and complete cycle also shown as we have discussed in the previous slide also. Longitudinal waves, sound is the example of it. A wave in which particles of medium vibrate in the parallel direction, that is angle is 0 between the direction of movement of particles and propagation of the wave. I am repeating again. A wave in which the particles of medium vibrate in the parallel direction of the propagation of a wave is called longitudinal wave. They can travel in solid, liquids and gases. Sound is the example of it. Can travel in solids, liquids and gases. The part of wave in which particles of medium are closer to each other is called compression. Compression meaning is particles closer. The part of wave in which particles of medium are farther apart, means far away from each other, is known as rarefaction. Rarefaction shows here particles are far away. Here is a tuning fork in the figure, and rarefaction, particles are far away. Compression, particles are closer, is shown in the figure. Here is a slinky. Slinky is a soft spring in which compressions and rarefactions are produced. If you are stretching slinky, then this soft spring clearly shows turns are closer, that is compression, turns are far away, and it is rarefaction. And this can be shown in the second figure, just like vibrating. It is producing vibrations about the mean position, just like a serpentine is moving on the ground, and it shows here up and down, that is crust and trough in the transverse wave also. In the figure, speaker is producing a sound. Molecules are closer, then it is a compression. Molecules are far away, it is a rarefaction. Then compression, rarefaction, compression, rarefaction successively. The pressure and density is more in compressions. Pressure and density is less in rarefaction. In the figure second, pressure variation is shown. In figure first, density variation is shown in compression and rarefaction. In the last figure, there is a graph for density and pressure variation about the mean position, that is in comparison to the mean position. Compression, yes, and rarefactions are produced in longitudinal wave, whereas crust and troughs are produced in transverse wave. Here is a comparative study between transverse and longitudinal wave. Transverse wave, longitudinal wave. In a transverse wave, the motion of particle is perpendicular to the direction of propagation, means traveling of wave. In longitudinal wave, the motion of medium particle is parallel to the direction of propagation of wave. Point number 2. Light and other electromagnetic waves are transverse waves because electric and magnetic vectors vibrate in perpendicular direction to the propagation of wave. Sound waves, compressions, rarefactions are produced in sound waves, and these are longitude waves. Derivation of velocity is equal to frequency multiplied wavelength. First, definition of wavelength. In one time period, capital T, the distance travelled by the wave is equal to wavelength lambda. Second definition of wave velocity. In 1 second, the distance travelled by the wave is wave velocity. If we are combining the two definitions, then the wave velocity is equal to wavelength upon time, and this gives these are the questions showing here time period calculation and wave velocity as per as example v is equal to n lambda we have discussed in the previous slide.